All right, we're back for Unit 1, Day 4. Today there are notes. I have them in front of me off to the side. And what I've tried to do is give you an example of each style of question. For the most part, when I look at the notes, and I have them on my iPad here, the idea is there's an initial question and there are 5 examples. The way this particular video has been made, I'm going to recommend that once you do or you see an example, you pause the video and you try to complete whatever question or questions or tasks looks similar to that video portion. If you do that and you follow the video closely, these bottom questions will go fairly easily, even though they're scary looking. And the top, I don't really need you doing anything on the top besides writing the number values in and essentially answering the question, is there a difference? So I should expect to see some numbers here, and then the answer yes or no. And you can follow that along with me. Before we begin, let's review what we're doing. It's Unit 1, Day 4. We're dealing with compositions or collections of exponent properties, and a review of those exponent properties. Anything to the 0 power equals 1. Anything with a negative exponent is that same thing positive on the opposite side of a fraction. When we have the same base with 2 different exponents, or even the same exponent for that matter, I add those exponents together. When I'm dividing, same base, I have the top minus the bottom exponents. And if I have a base of A with with powers, then I multiply. Those are the 5 rules that we're living with. And we're really just combining them together and just making more and more complex questions as we go. So I have 4 examples for you today. I'm sorry. I have to go back to that first question. Is there a difference between? I have it ready here. So is there a difference between? Now I've changed my numbers a little bit, so you'll have to do some computing, but otherwise this will tell you exactly how to answer your questions. And I'm going to use red so it stands out. The first task is there a difference between something that's negative being squared versus something that's negative not in parentheses being squared? And I'm going to tell you the answer is definitely yes, there is a difference between them, and I'll show you why. In this example, what's being squared is the thing that the exponent is touching, which means what's being squared is the parentheses. That means that I'm going to write the parentheses 2 times. This should look familiar. We've done this before. So that's -4 times -4, which is positive 16. Your example was -5 and -5. On the right-hand side, what the exponent is touching is the 4, not the parentheses, because there isn't one. So that means the 4 gets written twice, and this negative sign does not. It just gets written once because it's not being squared. And -4 times 4 is -16, and you can see that they are different. So is there a difference? Yes. And the difference with 4s is, like I've shown, you can figure out the difference with 5s. Pause the video if you need to. Now, same question with cubes, something to the 3rd power. In this example, the answer is no, there is not a significant difference, at least not one that we see in the answer. The rule is the same. The 3 or the cube or the 3rd power is still to the 3rd power around the parentheses. So that parenthesis gets written 3 times with multiplication. But the rule for negative times negative, this becomes a positive. And if both of those become positive in this example, 16, and we multiply positive 16 times -4, I have a positive times a negative, and I end up getting -64. On the other side, if I have a cube touching not the parentheses, but just the number 4, and we multiply 4 times 4 times 4 together, and just like we did on the previous one, the negative kind of comes along for the ride, you're going to find yourself getting -64 again, and you can see that they are the same value. So there are times when the parentheses matter quite a bit, usually when you're dealing with even exponents, and there's times when the parentheses don't matter as much, like when you're dealing with odd exponents. Now that may come into play as Get More Math throws some stuff at you. We have 4 examples today. Let's go ahead and dive in. The first example involves exactly that thing we've just talked about. In this first example, I have 2 bases. Let's be clear, -5 and -4. They're not the same, so I'm not going to be able to apply most of the rules that I know. But I do know, that the square is touching the parentheses. So on the top, I have parenthesis times parenthesis, which is going to equal 25. And on the bottom, I'm going to have the 4 times 4 with the negative coming along for the ride. If you type this in to Get More Math, it will accept it. If you type negative 25 over 16, basically just writing the negative sign on top, it will accept that as well because they are both the same thing. They are equivalent values. That should get you through your first example. Now for the second and third example, so again, as I mentioned before, pause the video. You might want to complete the example, then come back to the video for the second and third example. So this one question will help you with the second and third example. Now, in both of those examples, they are similar to this in that there's exponents on top, there's bases on top, and there's bases on the bottom. Sometimes these bases are the same, like in example 2, and sometimes like this one, the bases are different, like example 3. Regardless, here's how this works. We have a division sign here. We have a fraction bar, and that separates the top and the bottom. So let's go ahead and deal with the top first. And we happen to have the same base. But before I can even do this, I have to deal with this piece. So I have 3 to the negative 1 times 5 is negative 5. And 3 to the negative second, we'll get to that in a moment. And I guess while I'm working on the top, let's keep working on the top. 3 to the, let's see, these are adding, right? This was multiply, but when they're side by side, they add. So negative 5 plus negative 2 is negative 7. And I sure don't like negatives, so now I'm going to essentially just do this. And that's what I've done with the 3's. Now, as for the 5 to the 10th, there's no other 5's anywhere as a base in this whole question. So the 5 to the 10th really doesn't do anything. It shows up in the second step, it shows up in the third step, and it shows up in the fourth step. I'm running out of space. That leaves a space on the top. We don't want to leave a space on the top. We'll use a placeholder, and that is your answer. You should be able to do something similar to that for example 2 and 3. And since they're not numbered, let's be clear, example 2 is this one and example 3 is this one. Once again, pause the video right now, complete those questions if you need, and then start it up again when you get to example number 4. Example number 4 looks like this. Now there's a lot going on in example number 4. I even use some of the same variable bases. X's, Y's, Z's, and even some W's. So let's decipher what we're looking at. First, I see a fraction bar, so I have the top and the bottom separated. When I look at the top, I see bases of X, Y, and Z, but nothing in common. On the bottom, I see W, X, Y, and Z, but nothing in common. So what that makes me think is, well, I'm not going to have that same base rule where I add. What I am going to look for instead is actually, well, let's go ahead and see what's not being dealt with. I see I'm going to have a pair of X's that I have to deal with because those have the same base. I see I'm going to have a pair of Y's because those have the same base. And I can observe that I'm going to have to deal with a pair of Z's because they have the same base. But notice this W doesn't have anything. This is a lot like the previous question where I had, what was it, 5 to the 10th power on the bottom? And we just wrote 5 to the 10th power from left to right. This W is, well, it's on the bottom. And nothing else is going to change that fact. So I'm going to go ahead and write my W on the bottom, and that W piece is now kind of done with. We don't need to worry about it anymore. Now, for the next 3 pieces, I'm going to write each of my answers on the top because that's how the rules work. Whatever I get for my X is going to go here, so let's go ahead and do that. X on top and bottom means same base, so I keep the same base. 5 minus negative 1, that's the rule. It's subtraction, so 5 minus negative 1. 5 minus negative 1 is 6. Same bases are Y's. 3 minus, remember this, 3 minus 1. 3 minus 1 is 2. And Z's, same base. 7 minus 4 is 3. And what I like about this, I'm going to rewrite it because I have these circles here, but you'll notice that there are no other X, Y, Z, or W pairings. There's no other bases of the same letter, and there's no negative exponents anywhere. That tells me that my answer is X to the 6th, Y to the 2nd, Z to the 3rd, over W, and I'm done. I would have been done here, but I just didn't write it very neatly. And the last example, once again, pause the video if you need to, so you can do example number 4. And here comes an example of example number 5. It looks probably to some degrees worse than the previous one. There's a lot going on, and there's a lot going on in your notes as well. So let's go ahead and get into it. I do have a fraction bar, so I have a top and bottom separated. I have bases of 6 and 7 on the top. On the bottom, I have bases of 3, 6, and 7, so I don't have any immediate combining I can do, but I do see some power to power action. So let's go ahead and get into that. 6 to the negative 2 and 3, so negative 2 times 3. Negative 2 times 3 is negative 6. And I have 7 to the third power, and that doesn't really do anything, so I just write 7 to the third power. It doesn't do anything because there's nothing to do. On the bottom, I have 3 to the 2 times negative 1. 2 times negative 1 is negative 2. 6 to the negative 10. For now, I'm going to go ahead and leave that alone. 7 to the 8. And now I'm going to try my step number 2. Now, just like I did up here, I hope I don't run out of paper, I have 6s that go together. I have 7s that go together, but I have this guy here. Now I am going to cheat this a little bit because of spacing. So watch what I'm going to do. I know that the 3 to the negative second doesn't get impacted and it's sitting on the bottom. So normally I would write it right here. But I also recognize that it's a negative exponent. So to get rid of the negative exponent, even if I write it 3 to the negative second, I'm going to have to move it to the top to make it positive anyway. So I'm going to do that all in one step. Hopefully you can follow what I'm doing there. I might do some similar stuff with my 6s and my 7s. Let's see what we can do here. I see the 6s, so I'm going to go ahead and write these here and here, and if I need some space below, we'll use it. I have 6s as a base, negative 6 minus negative 10. Now for you, those of you who need it, that's negative 6 minus negative 10. Negative 6 minus negative 10, I keep, change, flip. So negative 6 minus negative 10 becomes negative 6 plus 10, and that's a 4. And now I'm going to do the 7s. 7s, top and bottom, make a 7. 3 minus 8 is what we're doing. Keep, change, flip. I get a negative 5. And I'm all done with my 3s, my 6s, and my 7s. I wish this were my answer, but I have a negative exponent. So now, and if I only had a little more space, so let me slide over just a tiny bit. I bet we can make this work. So watch how I'm going to simplify this. I'm going to go ahead and create my fraction one more time. I'm going to leave 3 to the positive 2 on, 3 to the positive 2 on top. I'm going to leave 6 to the positive 4 on top with a multiply sign in between. And the 7 to the negative 5 is going to come down to the bottom and become 7 to the positive 5. And now I have myself my answer. So this video was different than the others. It did incorporate multiple different exponent rules, but it was meant to do kind of watch an example, pause the video, complete a problem, replay the video. Hopefully that helps you get through Unit 1, Day 4.